A sample of bacteria is growing at a rate of 9% per hour and can be modeled by f of x equals 4 times the quantity 1.09 to the x power, where the input x represents elapsed time in hours and the output f of x is in millions of bacteria. A, what was the initial number of bacteria? Well, that'll be the same as f of 0. So f of 0 is equal to 4 times 1.09 to the 0 power. 1.09 to the 0 power is 1, and 1 times 4 is 4. So the initial number of bacteria would be 4 million bacteria. B, evaluate f of 5 and interpret the result. F of 5 would equal 4 times 1.09 to the 5th power, and using our calculator, 4 times 1.09 to the 5th power is equal to 6.15, about 6.15. So interpret the result. 5 hours later, from the initial time of 0, 5 hours later, we would have about 6.15 million bacteria. C, does this function represent exponential growth or exponential decay? Well, notice that as our values of x increase, our function values are increasing, so this would be exponential growth. D, estimate the elapsed time when there were 8 million bacteria. So we want to find the value of x that causes the function to equal 8. So we would have 8 equals 4 times 1.09 to the x power. So we'll start by dividing both sides by 4. That gives us 2 is equal to 1.09x. Now we'll convert this to a logarithmic equation. So x would equal log base 1.09 of 2. And then using the change of base formula, x would equal log base 10 of 2 divided by log base 10 of 1.09. And using calculator, this is approximately equal to 8.04, so we'll say about 8 hours later. So the last answer, how much elapsed time, or estimate the elapsed time when there were 8 million bacteria, you would say about 8 hours later.